When we talk about designing for people, it's easy to focus only on the mechanics of the system. However, if we want to make design choices that are optimally human-centered to help people, we need to really understand where we as engineers can actually influence a system. And that's where the human system model can help us kind of better understand this relationship. Now, the human system model begins with the user, the human at the center of the work. Now, the user might be a plant worker, a nurse, a technician, a driver, or a pilot. They should be considered an integral part of the system being redesigned, as every design decision ultimately affects them. The other side of this relationship is the system itself, and that can take many forms. It might be a piece of equipment, a software interface, a physical workspace, or even an administrative process. We are really surrounded by systems and we interact with them all the time, often without realizing just how much they shape our performance and our safety. Humans control or use the system by inputting commands, making choices, and initiating actions. Then they receive feedback or effects from the system, sometimes visually, sometimes physically, sometimes through sound or motion. And that feedback shapes how they interact with the system and helps them decide what it is they want to do next. It's a constant loop. From an engineering perspective, those 2 points, control and feedback, are our opportunities as engineers to influence design. We can shape how humans interact with the system and how the system itself influences or communicates back both physically and cognitively. That's where human factors comes in, to ensure those points are designed in ways that are usable, safe, and aligned with human capabilities. But there's more to it than just the interface. The design of any system is shaped also by external factors, things we don't always have control over but must account for in our design. Take the environment. Noise, temperature, vibration, lighting. These all affect how usable a system really is. A control panel, for instance, that's easy to use in a quiet office may be totally unreadable in a dim, vibrating truck cab. The goals of a system matter too. Are we building for a task that requires accuracy, speed, precision, monitoring, or even survival? Well, the design has to match the system's mission. Then there are the assets: time, funding, facilities, available labor, tools and materials. These determine what's possible and the trade-offs that we have to make in designing the system. And let's not forget about culture either. Things such as workplace morale, risk tolerance, demonstrated management support, incentives and rewards, and autonomy all affect how a system will be used, and ultimately its performance. So when we're talking about designing systems with people in mind, we're not just talking about the interface. We're talking about everything that shapes that interaction, from the physical and cognitive demands that we place on the user, to the environment, to the mission, to the culture that is used within.